Good morning, fourth grade students of room 302. Hope you had a nice Thursday night. I know I did. Time for Eureka Math. Eureka, it's a Latin phrase. What does it mean in English? It means I have found it, and what have we found? We have found the best way to learn math, and that, ladies and gentlemen, boys and girls, damas and caballeros, is more valuable than gold itself. All right, let's take a look at last night's homework. It's lesson 10 homework. Make sure your name's on there and the date. And let's start out, we're just going to scatter around and do a couple. We're solving using Los standard algorithm. So let's do B, 41 times 9. Okay, it's pretty straightforward. 1 times 9, as we all know from the identity property, is 9. And then we just do 4 times 9, 36. There we have it, 369. Let's go down and do D. And we'll do 286 times 7. A little more complex T's going on here. 6 times 7. What is 6 times 7? It is 42. There's my 2. There's my little 4. So it's 42. Come back up here and we say, okay, 8 times 7. Well, it's actually 7 times 8 tens, or 80 times 7. So we're going to have to think about it in those terms, okay? So 8 times 7, 80 times 7, 7 times 8 tens is 560. However, we got to add this 4 on. So 56, or 560 plus 40, I know it's kind of complicated, will give us 60. So I'm going to put a 0 here and cross out that 4. And let's get another color here to show that we're now dealing into the hundreds. So that's 60. I'll put a 6 right here. Okay? So we had 80 times 7 was 560, plus that 40 made it 600. Okay? 200 times 7. Well, I know 2 times 7 is 14, but I need to add these 6 onto it. So 2 times 7 is 14, 14, 15, 16, 17, 18, 19, 20. So we would just put a 20 here and cross that out. So our answer is 2002. Now you might be saying, how could I double check this? Well, think about it. I could round this up to 300 times 7. 0 times 7 is 0, 0 times 7 is 0, 3 times 7 is 21. Pretty darn close, okay? So I think I'm in the right neighborhood. Let's continue on to get into our thousands, the thousands, and we'll go and write this puppy up as 4,096 times 4. Okay, 6 times 4. 6 times 4 is 24, 6, 12, 18, 24. There's my 4, and there's my 2 tens. Okay, let's do 9 times 4. 9 times 4 is 36. In this case, it's 9D times 4, which would be 360, but plus those 2 would make it 380. So I'm going to cross that out. We'll put the 8 here and the 3 up here. All right, now I have 0 hundredths times 4. Well, that's 0, right? But I need to add these 3 hundredths from our last equation. So I'll cross that out and put 3 right here. And that leaves me, last but not least, with 4,000 times 4. 4,000 times 4. 4 times 4 is 16. And we're already in the thousands, 10,000s and thousands place. So there's our answer, 16,384. Let's give one more shot. Let's shift gears a little bit and go over here to G. And G is reading, if you can see this all nice and neat, 4,096 times 8. And notice how I put the multiplication sign all the way out here. It gives me a little more room to work with. So 6 times 8 is 48. 8 times 6 ones. There's 48. Now I'm going to 9 times 8. 90 times 8, or 8 times 9 tens, would be 72. but I need to add this 4 on. So 72, 73, 74, 75, 76. So I'll put a 6 here and cross that out and put a little 7 there. We go into our hundredths place. 0 times 8 is 0, but we add the 7 on, and we're all good. And last but not least, 4 times 8 is 32. Don't need to add anything on. I forgot to cross that out. So we're at 32,768. So you're going to take this time to put your homework away, pause the video, and put your homework away into the homework drawer. And welcome back. Let's take a look at what we got going on today. It's a pretty exciting lesson, if you ask me. We're going to connect the area model. So this is something kind of, well, not new, but new in the sense of multiplication and the partial products method. We're going to connect those to the standard algorithm. So we're going to be doing multiplying in a lot of different ways. And look at the way we come right off here, multiply in 3 different ways. Wow. Right from the get-go. All right. Let's go ahead and tackle this. Please follow along. I'm going to get an ink pen with a little more oomph. And we'll do 43 times 2. Go ahead and say that in your head with me, 43 times 2. We can also call this 4 tens, and write this down, please. 3 ones times 2. So we could break this down further. Take a look at this. Parentheses. I hope Math Mutt doesn't show up. He's always seems to show up when parentheses come around. 40 times 2, right? 40 times 2 plus 3 times 2. That's one way of looking at it. Now let's show it using place value disk. Ready? I think I'm just going to need tens and ones. There's ones, there's tens. How many ones do I have? 3. How many tens do I have? 4. So we're looking like that. What do? I multiply each of these by 2. There we have our place value chart. Disk, excuse me. And then let's just do the standard algorithm of 43 times 2. We're all going to get the same answer, right? Sure. 3 times 2, there's our answer there, is 6. And 4 times 2, there's our answer there, 8. Same thing up here. 40 times 2 is 80, plus 3 times 2, which is 6. And right here we have 86. So that's multiplying in 3 different ways. Hope you enjoyed that. I know I did. We're going to move right along at our rather rapid pace that we always do. This problem will be on your backside here. I have the master copy. So we have an application problem. And we have to do a little drawing on this one for us to do. It says write an equation for the area of each rectangle. Then find the sum of the 2 areas. So we're going to write an equation for the area of each rectangle. That means we're going to be drawing 2 rectangles. Then find the sum of the 2 areas and do your best. So let's do the first one. It's kind of a long, skinny rectangle. And then we're going to do one that's the same width as the long one here. Same width. So it looks something like this. This is 8. This is 30, and it's just units, so no meters or miles or anything like that, and that's 4. So we're trying to find the sum of the 2 areas, the total. We need to add them together, these 2 areas. Well, this area we can find out right away. We can just go like this, right? 8 times 3 tens. What does that equal? It equals 24 tens. And 24 tens equals 240. So we already know the area of this is 240. 8 times 30 is 240. What we don't know is the area over here. How are we going to figure that out? Well, we know this is the same length, right? So all we have to do is 8 times 4. So I'm going to go over here and 8 times 4. and that equals 32. And so there's the area of this smaller shape. But we need to find the sum, the total of all of them together, okay? So what we're going to do is add them together. And that would be 240 plus 32. There's 272. So 272 units. There's another way we could have approached this. Are you thinking? I know I am. We could have gone 30 plus 4 is 34, and just 34 times 8. So go ahead and write 34 times 8, and we'll tackle this one using, let's use standard algorithm. So 4 times 8, we've already shown that that's 32. Put my tiny 3 here. 3 times 8 we know is 24, plus the 3 would be 27. Excuse me. So, we can write a sentence now. The area of both rectangles all together now is 272 units. So we had to add those to get the sum. Excuse me. So we did 80 times 30 to get 240, then 8 times 4 to get 32 and added them. However, we also, as we saw, as we proved, 30 plus 4 times 8. So 34 times 8 also equal 272. So there's two ways we could get around that. So let's take a look at the area model. This is going to be new and exciting, I hope. And it says to multiply a 3-digit number by a 1-digit number using the area model. Okay, the area model is going to be a little new for us, all right? And that's okay. So let's start out with a problem of what? What am I doing? We're going to make an area model. Are we ready? Here we go. We're going to draw a rectangle with a width of 8. Let's draw this rectangle. Make it a little longer. We have a width of 8 and a length of 200. So let's just find the area of that now for kicks. What would it be? Well, think about it. 8 times 2 is what? 8 times 2 is 16. And then we have the 2 zeros because we're multiplying by 200. 200, 400, 600, 800, 1,000, 1,200, 1,400, 1,600. There we have it. So now we're going to kind of go into an expression to show how we could use this area model to solve something a little more complicated. Are you with me? We're with you, Mr. Leggett. So what we're going to do is we're going to do 234 times 8. Okay? And now let's make a tape diagram of this, or an area model, not a tape diagram, so sorry. And we're going to add some stuff onto that. We have 234, it's not just 200, so we're going to go all the way out here. All right, so let me just check my camera. Looking pretty good. Tilt up a little bit. So let's get to it. We're going to multiply 8 by 200, right? 34. And this is all brand new to you, so I'm going to take kind of slow. All right? So we have 8 times 200, 8 times 30, 8 times 4. You see why it's called an area model? Because we're kind of figuring out the area of each block. So let's start out with 8 times 200. We already have that answer. 1,600. Right? But now 8 times 30. So 8 times 3 is 24, but we have that 0 up there because we're multiplying 8 times 3 tens. So 8 times 3 is 24, and we add on the 0. Finally, we don't need to worry about the 4 ones because 8 times 4 is 32. Now, how would this work when we're talking about partial products? We're going to kind of go into reverse, but let's just see what's happening here. So, this is 8. That means times when there's nothing there. 200 plus 30 plus 4. Okay, so 8 times 234, right? That's what that means. So let's do the first leg of this with Mr. Leggett. We're going to do 8 times 200. Okay, we've already figured out what 8 times 200 is, right? 8 times 200 is 1600. So I'm going to go and do 1000, and notice how I'm lining up the place values the best I can. So 8 times 200. And then we're going to add on 8 times 30. 8 times 30, we already know the answer to that. Plus 8 times 30. Okay, what's 8 times 30? It's 240. So we can go, and we'll do 240. All right? And then we're going to add on what? We're going to add on 8 times 4. Oops, parentheses. I'm surprised Mathma hasn't shown up. He loves those parentheses. So I'm going to zoom out a little bit and tilt up a bit so you can see everything nice and clean. That's pretty good. So now we have 8 times 4. What's 8 times 4? We already figured it out in our area model. It's 32. I didn't do a very good job on that. 32. Time to add them up. Add them up. So 0 plus 0 plus 2 is 2. 4 plus 3 is 7. 6 plus 2 is 8. And we just bring the 1 down. We have 1,872. Now, ladies and gentlemen, boys and girls, damas and caballeros, we did it on area model. We did it kind of partial product in reverse. Let's take a look at standard algorithm. And you'll see a thing of beauty. 234 times 8. Dun, 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 dun. So 4 times 8. We know what that is from our area model up here, right? 4 times 8 is 32. There's my 2. There's my 3. 32. 3 10s, 2 1s. Let's continue on. 3 times 8. Well, we know 3 times 8 is 24. We add the 3 to get 27, right? 24, 25, 26, 27. So we'll put a 7 here, a little 2 up there, and cross that out. See how this is working out? I do. See, we have 272. 240 plus 32 is 272. It's all making sense, Mr. Leggett. It's all making perfect sense. So our last thing we're going to do, 200ths times 8, 8 times 200ths would be what? 16, but we have to add on that little 2. It's not a very good 2. 16, 17, 18, cross that 2 out, and there we have it, 1,872. So we got 1,872 here, 1,872 doing the partial product, 1,872 doing the area model, okay? Let's continue on. And we have, we're going to multiply a 3-digit number by a 1-digit number, connecting the area model to the standard algorithm. So let's make a big old area model first. I like those big old area models. And I'll use the nice pen. I don't like that pen. That's not my style. Let me find a pen I want to deal with. Here we go. So let's start with this equation. 316 times 4. So we have 316 times 4. We're going to make an area model, okay? So we have our 4 here, and we're going to multiply it by 300, by 10, and by 6. 300, 10, 6. See how that works? So 4 times 300ths. Go ahead and write that down. 4 times 110. And last but not least, we have 6 1s. 4 times 6 1s. And that's what our area model is looking like. I think you'll really like doing these once we get the hang of it. So 4 times 3 hundredths is 12 what? Hundredths, yes. 4 times 1, 10. Well, 4 times 1 is 4, but we throw in that 0 to show that it's 40. And then 4 times 6 ones. 4 times 6 is 24. 24 even. All right, so now what we have going on here is 4 times 300 plus 10 plus 6. And we could break this down further. We're getting into algebra, my goodness. 4 times 300 plus 4 times 10 plus 4 times 6. We see how that works? We know 4 times 300 is 1200. We know 4 times 10 is 40. And we know 4 times 6 is 24. Right? Right. So let's see how this stacks up in the partial products, okay? So we're going to do 316 times 4 vertically. And we're just that kind of partial products in reverse. 3 hundredths times 4 is 1200. 110 times 4 is 40. 6 ones times 4 is 24. Now we're ready to add. There's 4, there's 6, there's 2, there's 1. We have 1,264. Let's crack this puppy in the standard algorithm world. 316 times 4. Go ahead and give that a try. I'm going to let you get a head start. So write that down and give it a try. And we could say 6 times 4 is what? 24. Remember, up there? See how it's all tying together? There's my 4, there's my 2. 1 times 4 was 40, but we got to add on that 2, so it's a 6. And then 3 times 4 is 12. 1,264. Okay, our last little bit of work today before we go into our problem set is this. We're going to solve a word problem using the standard algorithm, the area model, and partial product strategy. My goodness, we're going to use 3 different ways to solve this word problem. So I'm going to zoom out because I think we can see my pen nice and neat enough, okay? So let's look at our problem. Let's underline what we know. A cafeteria makes 4,408 lunches each day. I'm going to circle that. It's asking us how many lunches are made on Monday through Friday. Well, Monday through Friday equals 5 days. So there's our problem. What does it look like we're going to be doing? It looks like we're going to be multiplying 4,408 times 5. That's exactly what we're going to be doing. So let's get right to it. Let's make our area model first. Okay, we have our area model, and we're doing 5. 5 multiplied by what? Well, the first thing we have is 4,000. Ay. 4 thousands. Wow. I didn't know I'd be dealing in thousands so soon. I'm going to change pens, not for any reason, but just one's a little thick. The next number we have is 4 hundredths up here. So it's going to be 5 times 4 hundredths. The next thing we have is 0 tens. I could have made a little more room, but I have 8 ones left. There's my 8 ones. 8 ones. So, time to get back to that thing we do. We have 5 times, that means times, and it's right next to it, 4,000 plus 400 plus 8. Or we would have 5 times 4,000 plus 5 times 400 plus 5 times 8. That's how our problem is shaping up to me. Let's first tackle 5 times 4,000. Well, I know 5 times 4 is 20, right? But I have these 3 zeros because we're dealing in thousands. So 5 times 4 thousands must be, ding, 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 20 thousands. Oops. I'm just going to write that out in standard form. 20,000. 5 times 400. Well, what's 5 times 4? 20. So it must be 20 hundredths. 20 hundredths is also known as, if you said 2,000, you're absolutely correct. Now we have 5 times 8 ones. 5, 10, 15, 20, 25, 30, 35, stop! 40. There we have it. Now if we add it, 20 plus 2,000 be 22,040. Let's see if this holds up using the partial products and the standard algorithm. So let's do the partial products first. 4,408 times 5. 8 times 5, we already know what that is. 5 times 8 ones is 40. 0 and 4. 0 times 5 is 0, plus the 4 is 4. 4 times 5 is 20, so I'm going to put a 0 here and a little 2 right there. And then finally, 4 times 5 is 20. Well, we got to add 2, and lo and behold, I'm doing the standard algorithm, not the partial products. So sorry about that. But we have the same answer, do we not? Now let's do the partial products. 4,408 times 5. Here comes the partial, boys. 8 times 5, we know it. 40, right? 400 times 5, we know it. 2,000. This is why you got to line up your place values just so, or you're going to get all messed up. And finally, 4 times 5, 20, not 200,000, Mr. Leggett, 20,000. So sorry, 0, 4, 0, 2, 2, 22,040. All right, let's move on to our problem set. Boy, I get fast, don't I? Want to get home, I think, get some dinner. So we're getting to our problem set, and that is on page 37. And I'm going to have to zoom in for this because it's pretty tiny. So please get ready to zoom. Woo! We're zooming in. Hope this allergies are better now. All right, let's see what we got to do. And if you're comfortable, go ahead, and then you can pause or come back and check to see if you got it right. It says, solve the following expressions using the standard algorithm, the partial products method, and last but not least, the area model. So we're multiplying 3 different ways, all right, as you can see. Let's do the area model first. I kind of like this area model. I do like it. So we'll start with a 4 times 400 times 20 times 5. 425. All right. Let's go ahead and do this part. 4 times 4 is 16, but you'll see I have the 2 zeros up there because it's hundreds, so that would be 1,600. 4 times 2 is 8, and we have 1 0. 4 times 5, 5, 10, 15, 20, stop. Scholastic rock. So we have 4 times 400 plus 20 plus 5, or 4 times 400 plus 4 times 20 plus 4 times 5. And now it's time for our 2 favorites, the standard algorithm and the partial product. And this time I am going to do the partial product first. We've already pretty much answered it. If you just look at this, it's so clear. If you really study it and say, hey, I get this, the area model already solved the partial products for me. Look, 5 times 4, 20. 20 times 4, 4 times 20, 80. And 4 times 400, 1,600. All right, let's do the standard algorithm. 425 times 4. And we could use this as a guide. 5 times 4 is 20. 2 times 4 is 8, plus the 2 is 10. Bring up the 1. And 4 times 4 is 16, plus that 1 is 17. So by using the standard algorithm, I'm getting 1,700 even. Let's check with our partial products. 0, 0, carry the 1. 6 plus 1 is 7, and bring down the 1. We have 1,700. 1,700, 1,700, and 1,600 plus 80 plus 20 is indeed 1,700. Let's tackle our next problem. We have 7 times 554. So I'm going to do 7 times 500. 7 times 30, and 7 times 4. We'll start with the hundreds column. What's 7 times 5? 5, 10, 15, 20, 25, 30, 30, stop. 35. But because it's the hundreds column, I need to add on, guess what? 2 zeros. 7 times 3. Well, I know it's 7, 14, 21. So it'd be 21 but I got out on the 0 because I'm doing 3 tens times 7. And finally, 7 times 4, 7, 14, 21, 28. See why learning your math facts is very important? So down here we have 7 multiplied by 500. I can hardly fit that in there. 30 and 4. Or we go down here, 7 times 500, 7 times 30, and 7 times 4. All right, let's do the partial product dance. Now I like doing the partial product first because we have the answers right there. 4 times 7 is what? 28. 7 times 30, what is it? 210. And 7 times 500 is 3,500. Just a matter of adding it now. All right? I'm not going to add it because I'd like to do the standard definition first. 530 times 7. 4 times 7 we know is 28 from our area model. Put the 8 here and the 2 here. 3 times 7 is 210 from our area model. We know that, but we add on 2 to be 23 and bring the 2 up here. And 5 times 7 is 35, but we add on the 2 to make it 37. So I'm showing our answer is 3,738. Let's see if this holds true. 8, 3, 2, and 3. Excuse me, 7 and 3. So 3,738 is right. Going to head on over here to C. 209 times 8. So I'm going to do 8 times 200 times 9. You'll notice there's no 10. So 8 times 200. Well, I know 8 times 2 is 16. 0, 0. 8 times 9 is 72. So down here, I would go 8 times 200 plus 9. And then down here, 8 times 200 plus 8 times 9. All right, let's do the partial product first. 209 times 8. We already got our answers here. 9 times 8, 72. There's no 10, so we just go 8 times 2 is 1,600. Guess who's ready to add? We are. 2, 7, 6, and 1. 1,672. Now, time to visit Mr. Standard Algorithm. 209 times 8. This is going to be fascinating. 9 times 8, 72, right? We got it there, we got it there. Do this 2 and the 7. 0 times 8 is 0, but we got those 7s there, so we got to add the 7 to get 7, right? And then 2 times 8, 1,600, or 16. There we have it. Flip her over. And we're going to take a look at these. We're going to solve using the partial products method. That's why we read this. Solve using the partial product methods, okay? Kayla's school has 258 students. I'm going to circle 258 students. Janet's school has 3 times as many as Kayla's. Uh-oh. How many students are in Janet's school? Well, we're using the partial product. So all I have to do is 258 times 3. 258 times 3. All right, so set your problem up like that. Oh, I know 8 times 3. 8, 16, 24. So we're going to put 24 right here. 5 times 3 is 15, but this is 50 times 3, so it must be 150. And finally, we have the hundreds. So 200 times 3. Well, I know 2 times 3 is 6, so that must be 600. I have 4, 7, 7, and we could say Janet's school has 774 students. All right? And you can always pause that. Next instructions. Model with a tape diagram and solve. 4 times as much as 467. So let's get our tape diagram out. Or make one. We don't have one in our pocket. And I'm going to say 4 times 4 hundredths, 6 tens, and 7 ones. So go ahead and pause that if you need to catch up. That's fine. I'm going to continue on, and you can always hit, solve it yourself, or follow along with me. So 4 times 400. Well, I know 4 times 4 is 16, but we're in the hundredths area, so I'm going to put 1600. Then I know that 4 times, 6 tens, or 4 times 6 is 24, but it's 10, so 1 0. And 4 times 7 ones is 42. Let's look at this a different way. 4 times, excuse me, drawing a blank here. 4 times 400 plus 60 plus 7, or 4 times 400 plus 4 times 60 plus 4 times 7. That's what we get. But how do we figure this out? We add, like partial products in reverse. 1600, we got to get those place values lined up perfectly or we'll be in a world of hurt. There's 2, there's 8, there's 8, there's 8. 1,882. Our last one. Solve using the standard algorithm. It's standard algorithm time. The area model, the distributive property, or, so it's given a choice, the partial products method. Let's do the standard algorithm, okay? Are you with me? We're with you. Hey, here comes Counting Crow. Are you with us? Well, I think I'm with you. I prefer the standard algorithm overall. What's wrong with your voice? These winds have got my sinuses acting up. I see they have yours acting up as well too. Oh, yes, they do, Counting Crow. Yeah, very much so. Well, I'm going to go and, just put my 2 cents in for the standard algorithm, and I'm going to go enjoy a hot cup of lemon tea to clear my throat. Okay, Counting Crow, you do that. I can't even caw. Oh, I understand. Get better. Poor guy. So let's do our standard algorithm of 5,131 times, and you notice where I put my multiplication sign? Way out here. So 1 times 7. Think about the identity property. Any number multiplied by 1 remains the same. It's 7. 3 times 7. 7, 14, 21. I'm going to put my 1 here and my 2 right here to remind me that I got to add that 2 hundredths to my 100 times 7. Well, 1 times 7, or 100 times 7, is 7 hundredths, plus this 2, 800, 900. So I'm going to put a 9 there and cross out the 2. And now I'm left with just 5 times 7. 5, 10, 15, 20, 25, 30, 35. Stop! That was 7. And there's my answer. Now let's just check for reasonableness. I'm going to round this to the nearest 1,000, which would be 5,000, right? Much closer to 5,000 than it is to 6,000. And we'll multiply by 7. Watch what happens when we use the standard algorithm with this. 0 times 7 is 0, 0 times 7 is 0, 0 times 7 is 0, 5 times 7 is 35. My goodness, I think my answer is quite reasonable. I'm glad we checked for reasonableness. Alrighty. Get ready for your couple of exit tickets. Log on to Zern right now to get that math brain going and rolling. And we'll debrief and then get the exit ticket, okay? Great audience. Love having you guys in my class.